Why do humans have fingerprints? At first, they seem like a useless detail, just tiny ridges on your fingers that show up on everything you touch. In modern life, they're mostly associated with crime scenes and identity checks. But from a biological point of view, fingerprints are not random at all. They are a physical feature that likely evolved for a very practical reason, and that reason is grip. Your fingers are constantly interacting with surfaces that are not perfectly smooth. Skin alone is not very efficient at maintaining friction on dry or wet surfaces. So over time, evolution favored a structure that could improve contact mechanics between skin and objects. That structure is the fingerprint pattern. Those ridges increase friction in a very specific way. Instead of having a flat fingertip that slides easily, the ridges create micro-contact points. This improves grip on rough surfaces and helps prevent slipping when handling objects. But there's a second, less obvious advantage. Fingerprints help manage moisture. Your fingers are constantly producing sweat, even when you don't notice it. If your skin stayed completely smooth, a thin layer of moisture could reduce friction and make surfaces slippery. The ridge structure helps channel that moisture away, preventing a full water film from forming between your skin and objects. So fingerprints are not just about grip, they also stabilize grip conditions. But here's where it gets more interesting. If fingerprints were purely functional for gripping, you might expect every human to have identical patterns optimized by evolution. Instead, fingerprints are unique to each individual. Why? Because the exact pattern is not fully genetically controlled. During early fetal development, fingerprints form while the skin is still growing rapidly. At that stage, tiny differences in pressure, growth rate, and movement in the womb affect how the ridge patterns develop. Small variations in fluid environment, finger position, and growth timing all influence the final pattern. So while the general structure is biologically guided, the exact pattern is partly shaped by random physical conditions. That's why no two fingerprints are the same. But uniqueness itself was not the evolutionary goal. It is more of a byproduct of a developmental system that is sensitive to small environmental differences during formation. Still, that uniqueness turned out to be useful for humans in a completely different context. Identification, not in nature, but in modern society. The same feature that likely evolved for grip mechanics became one of the most reliable biological identifiers we have. There's also another hypothesis worth considering. Some researchers suggest fingerprints may also improve tactile sensitivity. The ridge patterns can amplify vibrations when fingertips move across textured surfaces, helping the nervous system detect fine details. This would be especially useful for primates that rely heavily on precise manipulation, grabbing branches, handling food, or using tools. So fingerprints may serve multiple overlapping functions: improved friction and grip, moisture control, enhanced touch sensitivity. And all of these advantages matter most in environments where precise hand control is critical. That's important. Because human ancestors depended heavily on manual dexterity. Unlike many animals that rely on claws, hooves, or paws, primates evolved highly sensitive fingertips for interacting with complex environments. So fingerprints are not an isolated feature. They are part of a broader evolutionary shift toward precision handling. But perhaps the most interesting part is this: fingerprints are not actually unique to humans. Many primates have them, which suggests this feature evolved long before modern humans appeared, in response to shared environmental pressures rather than human-specific needs. So what looks like a mysterious personal identity marker is really a functional surface adaptation that happened to be shaped by randomness during development. In the end, fingerprints are not there to identify you. They are there because gripping the world efficiently matters more than having smooth skin, and evolution built a surface that does exactly that, even if it means every person ends up with a slightly different pattern.